I think it's going. Yes, it's going. All right, I'm recording. Hooray. Okie dokie. So we're going to get started. Here we go. The first thing we're going to talk about, all right, we're in section 1.3, describing quantitative data with numbers. We're going to start by talking about the center. When we talk about center, measures of center, we mean the mean or the median. These are the two measures of center that we use, or that we will be using. Cooperating. There we go. Right. We have mean and median. Right. Those are measures of center. So we have our definition of the mean. Define the mean, otherwise notated as x bar, pronounced x bar, of a set of observations. Add their values and divide by the number of observations. If the n observations are x1, x2, x sub n, their mean is determined by this formula. All right. Now, this is just a fancy way of notating. Take all of your data points, add them up, and divide by how many data points you have. Okay. So this just, it's a lot of notation and a lot of symbols, right? The x sub 1 means this is the first data point, x sub 2, second data point, x sub n, this is the nth or the last data point. And we use these numbers and n's just because we don't know. This is a general rule, general example, right? Or in more compact notation, you can say x bar equals sigma x sub I divided by n. Right? And we use this to write all of that in a very short space. All right, sigma. All right, this little E-looking guy, this is sigma, a capital sigma. And it means sum. All right, so in this notation, it means add up all of the terms. You know, x sub I is just a general one notation that says anything that's like anything in my data set is represented by x sub I. So this little E looking thing is actually a sigma. It's a Greek letter, and it means sum. Add it all up. All right. And so, this, we should have probably seen this in previous classes. We should have heard of the mean. Now we're getting some more notation. So with the mean, we can do this example here. We have travel times to work for 15 workers in North Carolina, chosen at random from the Census Bureau. All right. We have 30, 20, 10, 40, 25, 20, 10, 60, 15, 45, 30, 12, 10, and 10. All right. So we're going to do this the fast way, well, relatively fast way, so we can get other things later. And we're going to use our graphing calculator. We'll slide that on in here. Okay. And we're going to put these into a list rather than adding them all up and not being able to do anything else with them later. So we'll start with 30, 20, 10, 40, 25, 20, 10, 60, 15, 45, 30, 12, 10, and 10. All right, excellent. I have 15 numbers in there. That means I didn't skip any. And now I'm going to have the calculator do my work for me. I'm going to go back to stat. I'm going to say calc, one variable statistics, and I need list one. Calculate. All right, there we go. So this first one, x bar, 22.466666. All right, we'll round up 22.5 is the mean. So rather than doing all the work, we can say x bar equals sum x of I over 15. Jocelyn, I'm not your little doodad means in the chat. Did you need me to stop and explain something, or am I going too fast? Okay. All right. So we've got our mean. Hooray! All right. So there's the mean. We use the calculator. We did use the calculator on purpose because now we have a bunch of other stuff that we can get from it. The next measure of center is the median. The median is the midpoint of a distribution. The number such that about half the observations are smaller and about half are larger. To find the median of a distribution, we need to arrange all observations in order of size from smallest to largest. If the number of observations n is odd, the median is the center observation in the ordered list. If the number of observations n is even, the median is the average of the two center observations in the ordered list. And this is hopefully something that you saw in Math 1 or Math 3. But again, the median is the middle. Put it all in order, it's the middle observation. And again, we're going to use the same list of numbers. I'm going to put them in order from smallest to largest. So we have, again, the calculator can do this, but I just want to demonstrate how this works. So we have 5, so we have 10, 2, 3, 4, 10. 12, 15, 20, 30. Oops. Skip 25. 30, 40, and 60. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I missed one. What did I miss? Oh, there's 2 40s. There we go. All right, and so now, the easiest way to find the middle when we have a short list is to start crossing things off. Oh, come on, man. It's crazy. All right, so based on what we did, the median should be 20, because that is the middle value, which means there should be 7 to the left and 7 to the right. So we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We've split my data in half. Right, roughly 50% on one side, 50% on the other, and the middle value left behind. Right, and just make sure we didn't do anything wrong. We'll bring our calculator back. And there we go. The median is, in fact, 20. Hooray. Right. The other shortcut in finding the location of the median, if needed, is take n, the number of observations, right, so find the location of the median. Right, this can be done by taking n, adding 1, right, and dividing it by 2. This tells me exactly where the center value should be in my set. Right, so instead of crossing off on both sides, I can just count to that number. Right. If we look at this example, we would have 15 plus 1 divided by 2, 16, second rate, divided by 2 equals 8. 1, 2, 3, 4, 5, 6, 7, 8. This is the 8th term in my ordered list. So we have a few different ways to find the median manually. But again, if we know how to use the calculator, once we put in our data set, we can pull a lot of information from the calculator and not have to do it manually. I'm showing you how to do it manually because you might be asked to show, like on the AP exam, might be asked to show how to find the median. And you can't like record you doing it on your calculator. You have to manually show how you would do it. So we need to know these by hand strategies. All right. What questions do you have so far?
Mr. Mosley?
Yes.
I can't get to the lists on my calculator.
Okay. So here, let's exit out of this. Make my calculator really big. All right. So to get to your list, I'm gonna exit out to my main screen here. If you're in the main screen, right, you're gonna hit Stat, and then right here the first option is Edit. Just hit Enter, and it'll get you to where you can actually enter items into your list.
Oh, I kept hitting the last option. My bad.
Oh, it's all good. No worries. Based on how the calculator is set up, you would think that you would go to where it says List. That just allows you to name your lists, which is, I don't know why that's the thing, but yeah, we'll be using that Stat button a lot, and that's where lots of our options reside, so to say. Here's the other thing we can do, which was on one of my videos as well, really briefly. We can order this from smallest to largest to make life easier if we're having to create a dot plot or something like that. And to do that, we go back to Stat, and we have these different options under Edit. We have Sort A and Sort D, clear list, set up editor. Sort A means sort in ascending order from smallest to largest. Sort D is descending order from largest to smallest. Typically, we want it in ascending order because that makes the most sense when we're creating graphs. So if I select the second option here and say Sort A, I'll then put in second 1, which puts in L1, which is list 1. Hit Enter. It's going to say it's done. So now when I go back to my list, now it's in order. Which would make, if I'm manually, again, making like a dot plot, this would make it much easier for me to be able to go just from left to right on my number line and fill in my dots. All right. Cool. Thank you for asking for clarification. All right. All right, so now we've got our mean, we've got our median. I want to show one other thing here. So we have a few little Greeks, and another Greek thing up here. This little guy that looks like a U with like a tail at the front is actually pronounced mew, kind of like a cat. It's mew, right? This is mu. Oh man, I can't write mu. It's a Greek letter. And this is actually the mean of a population, is what we use that symbol for in statistics. So if you have everyone in the population as your survey or your sample, and you calculate the average, then you would notate it with mu instead of x bar. X bar is the average of the sample. They're calculated the same way. It's just a notation that allows you or someone else looking at your work to know whether or not you're dealing with a sample or with a population. I'm going to do that. And then our x sub I, this represents the data point as a symbol. And we use I in math in this way as like a subscript to represent that I can replace that with any number. So like x sub 3 represents the third term or third data point in my set. So it's a labeling convention. All right. Sorry. Does anyone need from this part? Is anyone still writing stuff down? Please raise your hand. Okay. All right. So then we have this comparing the mean and the median. All right. The mean and median of a roughly symmetric distribution are close together. If the distribution is exactly symmetric, right, the mean and median are exactly the same. There's no difference between them. Right, so if we're looking at like a distribution that is like bell-shaped, right, or even if it's just like a straight across distribution, like it looks like a big rectangle, all right, the mean and the median are just going to be in the middle. They'll be in the same place. Right, so you'll have, x bar and the median reside in the same place. Right? In a skewed distribution, right, the mean is usually farther out on the long tail than is the median. These ones are symmetric. Right? When we're skewed, right, we'll have graphs that might look like this. Right? Or like that. This is a rough sketch. Right? So we have skewed left and skewed right. In these cases, your median is going to be still closer to like the peak. Because it still has to reside in the middle. Right? So 50% is on one side and 50% is on the other side. The mean, because it gets pulled towards the tail by the outliers or by the extreme values, moves the direction of the tail. Right? So the mean is going to move to the left in this case, and to the right in this case. Exactly where it is depends on the values. The more extreme values they have, the more the mean moves. Right? So this is how they're kind of related. And this can help us explain why we would use one rather than the other. All right? It doesn't make sense to use the average when we're talking about things like home prices. It's like, if I want to know what's the typical person going to pay for a home in Escondido, I would look at the median. Is that okay? The mean is going to reflect the extreme values, which is going to make the extremes are going to make the graph skew to the right, because there's some super expensive homes, right, in Escondido, and there's some really inexpensive, and there's most of them are in the middle, like in the middle of our values where the median is going to be. So if I were to look at the mean, right, the average home price, it's going to be much higher than the median, but that's because we have these extreme values that are pulling that mean towards the tail. And it's not an accurate reflection of what the typical person would be expected to pay for a home. So we have to make those considerations when trying to decide which should I use, the mean or the median, which is a better reflection of what would be expected or what is typical of that distribution. Okay. What questions do you guys have? Okay. Does anyone need another moment to write anything down? Please raise your hand. Okay. All right. So, and again, these pages will be posted into Canvas as well as the video, so you won't just have one or the other, you'll have both. Okay, so then we're going to move to the spread. Right. To measure spread, we're going to first look at range and the interquartile range. Right. The range is the simplest measure of variability. Right. And I want to point out the word variability, because that's what, when we're talking about spread, that's what we're really talking about. How much variance does our data have? How much, what's the spread? What's the range? How much does it vary from one end to the other? So we can call that variability. So you might see in questions, they might ask, what's the variability of this data? Instead of asking, what's the range? So they can kind of switch up the verbiage on you, so I want to point that word out. To compute the range of a quantitative data set, subtract the smallest value from the largest value. The range shows the full spread of the data. Right? But it depends on only the maximum and minimum values, which may be outliers. So the spread, if you're just doing the range, you could get a very large range, but isn't really indicative of the actual spread of the data, because you could have one extreme outlier that's making the spread seem much larger than it is, because if we exclude that one, then we get something that's more reasonable and is a better representation of how spread out our data typically would be or should be. Right? So in our travel example, we already know what our minimum and maximum are because we use our calculator. And it's in our summary statistics. I'll pull those up again. As it's still ready. So our minimum was 5, our maximum is 60, right? So that means, right, our min is 5, our max was 60. So the range, right, is going to be 60 minus 5 equals 55. Right, so our data has a range of 55 minutes. Right, we're talking about travel times. All right. So we could say travel times have a range of 55 minutes. Okay. And that's similar to, but not the same as saying travel times are between 5 and 60 minutes. Right? The range itself is a specific value. Okay? As like a mathematical term, range is a value, it's a number. But I can also say the data is between, and we can refer to that as the range of data. The range of the data falls between 5 and 60. I know that's a little confusing. So you have to read questions carefully to see what they're wanting. Do they want to know, if we're giving a general description of a data set, we want to tell them what everything falls between so they know what it looks like. If someone's asking what is the range of the data, what's the spread specifically, they want to know what value represents how far away the smallest is from the largest, and everything else falls within that range of 55 minutes. And again, range is something we've seen. We saw it in previous classes. It is minimum subtracted from the maximum. It is a single number. Next, we have our IQR. And the IQR measures the range of the middle 50% of data. All right, and that's an important thing. We're looking at the middle 50% of the data. This is the IQR. The process for calculating the quartiles and the IQR uses the rule for finding the median. All right, so let's see. Again, we had this example. Let me do this real quick. I want to hold this. Could be like that, isn't it? There, now I don't have to do that again. All right, so not cooperating. Okay, so now we've got our data set. We already found the median. Right. Yeah, it's not really. Sorry guys, I don't know what's going on with this. Falling behind. All right, well, either way, I'll fix that later. All right, so when we're calculating quartiles, we arrange the observations in increasing order and locate the median in the ordered list of observations. Right, we already have that. That is our median. The first quartile, Q1, is the median of the observations that are to the left of the median in the ordered list. Right, so we have this set over here of 7 data points. And then we have the other side, which is another 7 data points. I need to find the median of both sides to find Q1 and Q3, right? So our median over here is going to be this 10th term. And we call that Q1, or the number 10. It's the 4th term that falls in the middle. There's 3 terms on each side of this. On the other side, we have 30. It's Q3. So we find the median of the 2 halves, so to say. And then the interquartile range is Q3 minus Q1. Which would be 30 minus 10. And in this case, it is 20. So now we're getting a more narrowed in picture of the spread of our data. Right? The middle 50% of my data is within 20 minutes of each other. All right, there's a spread of 20 minutes, so to say, in the middle 50% of data. Whereas when I look at the entire set of data, there's a 55-minute range. Now I'm down to just a 20-minute range. So that means 50% of the people in the sample are within 20 minutes of each other as far as their commute time. Now it says, be careful in locating the quartiles when several observations take the same numerical value. Write down all the observations, arrange them in order, and apply the rules just as if they all had distinct values. Right? And we see this in the data set we have here. There's 4 10s, right? On this left side, I don't just write 10 once, I write each data point, even though it's a repeated value. You don't leave anything out. Right? And so the range and the IQR, right, these are 2 ways of measuring spread. We're going to get to a third one shortly here. Okay. What questions do you have? Does anyone need another moment on this screen to write stuff down? Please raise your hand. Okay. All right, I'm going to move to my next page of stuff. All right, so now we're looking at outliers and the 5-number summary. Okay, so identifying outliers using the IQR. This is one method of identifying outliers. It is a more common method. There are several others, but this is the first one we're going to talk about, and this is the first one we're going to use. All right, so we have 1.5 times IQR rule for outliers. All right. And in this, right, call an observation an outlier if it falls more than 1.5 times IQR above the 3rd quartile or below the 1st quartile. We'll look at this in a moment. Okay, so it's either past the 3rd quartile or below the 1st quartile by a certain distance. All right. And then we also have the 5-number summary. 5-number summary of a distribution consists of the smallest observation, the 1st quartile, the median, the 3rd quartile, and the largest observation, or the maximum, written in order from smallest to largest. That is, the 5-number summary is minimum, Q1, median, Q3, or maximum, and then maximum. And so we're going to look at a few different things here. I'm going to write out our 5-number summary here. Right, so we have minimum, Q1, the median, Q3, and the maximum. Right? Our minimum is 5, maximum was 60. Our median was 20. Q1 was 10, and Q3 was 30. All right. And from our previous page, we know that the IQR was 20. So if we're looking for an outlier, we need to run the 1.5 times IQR math and test for outliers in this data set. So 1.5 times the IQR is the IQR is going to be 1.5 times 20, which is 30. So if I add 30 to Q3, Q3 plus 30, that's going to be my upper bound, so to say, the upper boundary. Anything beyond that will be considered an outlier. That is going to be 60. And if we do Q1 minus 30, and Q1 minus 30 is going to be negative 20, which doesn't make sense for this context, right? So based on these, right, I don't have any outliers. My maximum is 60. I have to be greater than 60 to be an outlier on that upper side. I definitely don't have any negative travel time, so I don't have anything on the lower end. So based on this test, right, we have no outliers. Because I have no values greater than 60 and no values less than negative 20. So that's how we use this 1.5 times IQR test. Now, any questions on that? Okay. Our last thing here is we're going to make a box plot, which again, you may have seen in the past. Right? And we're going to use the same set of data. My number line is much larger than we need. That's okay. So that's how I like to make my box plots. Right. The central box is drawn from the first quartile, Q1, to the third quartile, Q3. So I'm going to mark where all my points are. I'm going to have 1 at 5, Q1 at 10, median at 20, Q3 at 30, max over here at 60. Right? So then we draw the central box. And then we need to put a line in the box that marks the median. And then lines, called whiskers, extend from the box out to the smallest and largest observations that are not outliers. We don't have any outliers, so we don't need to worry about stopping our whiskers early. Outliers are marked with a special symbol, such as an asterisk. Right? So if we had some outliers, they'd be like out here somewhere. We don't. So we're not going to put them there. All right. Sometimes you'll see box and whisker plots, these little end markers on it. It's okay to do that. And this is our box plot. They can also be called box and whisker plots. The nice thing about these is we can easily compare data if we want. The box plot represents the shape of the data as well. I can stack box plots from different data sets comparing the same units on top of each other to do a quick comparison. So we can get the summary of what's going on from a box plot. And it also includes telling us if there's outliers or not. So it can be very useful. Great. And we can make a box plot using our calculator. Right. So if I go to stat plot, which is right above y equals, I'm going to go in this first section here and work with plot 1. And you can see I'm going to turn it on so it shows up on my graph. I need to turn on my box plot. I'm going to turn this one on because the one that we're flashing on here will show outliers. I believe they're going to use the 1.5 IQR test. They might use this one in the calculator. I'd have to look into that. We'll hit enter. All right, see, this only needs one of my lists because it's working on a single set of data. I'll switch that back to L1. So it's going to give those. Now my graph is turned on. So if I just go to the graph, I can't see my whole box plot because my window's not set properly. I can see part of it. Yay, over here at the 5 and then at the 10. So we're going to have to adjust our window so that we can see our box plot. All right. I don't need to go to -10 on X. Right. I'm just going to go to 0. I need that maximum. Let's set it to 70. We'll go by 5, 0. Just leave that there. All right. And now when I go to graph, hey, look, there's my box plot. Got it kind of high up there. If I change that, it's to lower it. Yeah, it just throws it at the top of the screen, regardless of the y-axis.
Mr. Mosley?
Yes.
So, like, for the thing to show up, you still need the list, right?
Yes, absolutely. Yeah, it needs to be in the list, and you need to refer to that list in that stat plot menu.
Okay, thank you.
You're welcome. I believe so. If we go to trace, it's going to go through my 5-number summary for me. Right, so it kind of just goes through, and it actually labels them. I have minimum, Q1, median, Q3, maximum. So again, this is very useful, if you're drawing this by hand, to have a picture of what it looks like before you draw it. Right? We can help make sure we're not making any errors. Any questions on the calculator? Move our calculator. Now, does anyone need any more time to write anything down from this current screen? Okay. I'm going to quickly touch on the standard deviation, but I'll go into actually explaining how to calculate it next class. Your calculator will find this for you. That's the only reason why I'm going to mention it. Standard deviation and the variance measure spread by looking at how far the observations are from their mean. The standard deviation, S sub x, measures the typical distance of the values in a distribution from the mean. It is calculated by finding an average of the squared deviations and then taking the square root. This average squared deviation is called the variance. Right? That's this big long string of stuff here is the variance. Right? It's S squared sub x. Right? And the standard deviation is given by the square root of the variance. Again, we can calculate this by hand. It's a terrible process. But if we look at our calculator and we go back to our one variable statistics, right here where it has the x, that's the standard deviation. It's been calculated for us based on our data. Underneath it is also standard deviation. But this is the standard deviation of the population, if that 15 values were the entire population. This first one, Sx, is the standard deviation of the sample. So we will mostly be using the Sx unless otherwise told that we're talking about an entire population. And then to find the variance, if you have the standard deviation, you just deviation. So if something's asking you to identify the standard deviation and the variance, have your calculator do the work, get the standard deviation, and then on a piece of paper or something, write down as many numbers from the screen as you can. Whatever's there, write it down, type that back into your calculator, and square it. And that's the variance. That's the closest estimation of the variance we can get without doing it by hand, which we're not going to do right now. Okay, so that's a quick intro to standard deviation and variance, just as far as where to find them. We'll get into how to really calculate it and what it actually represents next time. Okay? So, what questions do you have? Okay. So once again, I'm going to be posting stuff into Canvas. I am done with the lesson, so I'm going to stop the recording, and then I need to speak to